This is 2.4 adaptations. So this is cardiovascular adaptations, and we're going to start off with the heart. For anaerobic adaptations, not many beneficial changes are seen. There may be some cardiac hypertrophy after lots of training. This is working the heart hard for multiple short periods of time, which increases the size and strength of the heart. Cardiac hypertrophy helps the oxygen transport to muscles after anaerobic work. Aerobic adaptations to the cardiovascular system also include cardiac hypertrophy. This is due to the heart working hard for long periods of time. This can help increase stroke volume, which is the amount of blood ejected from the heart after one beat. This occurs as the heart will become stronger. This therefore allows the heart rate to decrease, but still achieves the same cardiac output. As well as this, there's an increase in heart rate range, which allows there to be a delayed VO2 max. So this is cardiovascular adaptations of the blood. So here we can see capillarization. This means there's a growth and development of capillaries. This means there's an increased blood flow to muscles and therefore more oxygen delivered at the same time. EPO stimulates hematocrit. So there's an increase in red blood cells. There's a larger hemoglobin content, therefore there's a larger amount of oxygen available. Here we can see the makeup of blood. Blood plasma increases. This results in the viscosity staying the same, which is a positive. If the blood plasma was to stay the same, however, viscosity would increase as there would be a higher number of red blood cells. This is bad for the transport of oxygen. Respiratory system adaptation. An adaptation is the respiratory muscles becoming stronger and more elastic. This means that there can be a higher vital capacity as the lungs volume can increase more. Within more intense exercise, tidal volume can be larger as muscles can expand the lungs more, so a greater amount of oxygen can be consumed. Breathing rate can be higher due to the stronger muscles enabling greater contraction. This allows a higher VO2 max. Stronger muscles does mean there's slightly lower ventilation at rest due to larger and deeper breathing, allowing the breathing rate to decrease. Capillarization and alveolar increase means there's a faster diffusion of gases, meaning a faster transport of oxygen and carbon dioxide. Stronger muscles and better gaseous exchange means oxygen reaches muscles faster, decreasing time until the aerobic threshold is reached. This means the oxygen deficit is smaller as less time is spent compensating anaerobically. The smaller the oxygen deficit, the quicker the recovery, and smaller the epoch.